Hi guys, welcome to this page of the notes. So again, what we're doing is we're working our way through a couple of rational functions just to get ourselves some practice, finding x-intercepts, vertical asymptotes, and horizontal asymptotes using those three new rules that we just learned here in this section. Once again, this rational function is not really quite like what I would actually give you on a quiz or a test if you're taking this class with me, but it is still good practice for finding x-intercepts, vertical asymptotes, and horizontal asymptotes, and so that's what we're going to use it for. Let's just jump right into it. Here's our rational function, and as always, right down here, I give you the things that I'm going to need you to find. Use it kind of as a roadmap, right? Start here, then move to this, then do this. Once you've got those pieces, we'll kind of put them together and see if we can fashion together some sort of graph. Now, this one's going to be a little bit different than the other ones I'll have you do, but we'll get to that in just a second. First, x-intercepts. Let's talk about this for a second. If you guys remember the problem that we just did, right? The problem we just did, we had a rational expression. We set it equal to 0 to find where it crosses the x-axis. Now, if you remember, because I set it equal to 0, right, set it equal to 0, I had to multiply the denominator to the other side. But 0 times anything is always going to be what? Yeah, it's always going to be 0. So, a shortcut on all of these problems. Anytime you have a rational expression and you're looking for the x-intercept, don't even bother setting the whole thing equal to 0 because you know you're just going to multiply the denominator to the other side. It's all going to be 0 anyway. You can just skip right to setting the numerator equal to 0. So just another quick note for you here, because of the way the rational functions work and having to multiply the denominator to the other side where there's a 0, you can just, for these rational functions, find x-intercepts by setting the numerator equal, oh, that got weird. Right, just skip that step where you set the whole thing equal to 0, multiply the denominator to the other side, because it'll always wind up just being, right, denominator times 0 will always be 0, and you wind up every single time with 0 equals the numerator. So just skip straight to it. Find the x-intercept by setting the numerator equal to 0. Now, the only time that wouldn't work is if I give you a simpler rational function like we did in the previous section, where you had a value of k added or subtracted on the back. Right? Remember, the way that you solve that is you actually have to remove the addition or subtraction first, in which case you would no longer have a 0 over here, and so then when you multiply the denominator to the other side. But when k is hidden, right, that k is not easily distinguishable in this problem. It's kind of been hidden in the function. Right? I just have a numerator and a denominator. There's nothing added or subtracted back here. It will always just set the numerator equal to 0. The only way this wouldn't work is if you've got some number added or subtracted on the back out here, but that would be your value of k then anyway. So that's section 3. Those are much, much simpler problems. Let's keep going with these slightly trickier ones. So now, equipped with that new idea, let's just go ahead, find my x-intercept by setting the numerator equal to 0. Well, my numerator is an x plus 1 cubed. Well, in order to solve for x, since it's cubed, I'll have to take the cubed root of both sides, but the cubed root of 0 is 0, so I wind up with 0 is equal to x plus 1, and then I'll solve for x by finding that I'll subtract the 1 to the other side, and x is equal to -1. So here's what I now know. I have an x-intercept at x equals, wait, did I write that correctly? Yeah, so I have an x-intercept at x equals -1, and that happens to be the point -1, 0, right? It's 0 because I made y 0. Okay, let's keep going. Next, vertical asymptotes. Well, we know that we find vertical asymptotes when the denominator is 0. So, x-intercepts, numerator is 0, Vertical asymptotes, denominator equal to 0. Well, my denominator was an x plus 2 squared. So x plus 2 squared is equal to 0. To get rid of the square, take the square root of both sides, but the square root of 0 is 0. Subtract the 2 to the other side. There we go. I now know that I have a vertical asymptote at x equals -2. -2, I have a vertical asymptote. All right, so that'll be a vertical line on my graph, vertical line that my graph will approach but never touch, all right? X equals -2. Fantastic, that brings me to my last box, finding the horizontal asymptote. Okay, here you go. So the degree of the top polynomial, well, it was an x plus 1 cubed. If you were to FOIL all that stuff out, well, it's not really foiling because there's 3 binomials, so it would be an x plus 1 times an x plus 1 times an x plus 1. If you were to distribute all of that out, you'd wind up with an x cubed, right? The 3 is the power. So, degree 3 in the top, b of x, I had an x plus 2 squared, so that's x plus 2 times x plus 2, FOIL it out, you'll wind up with an x squared as the largest power, so that's going to be a 2. And I wind up then seeing here that a of x is greater than b of x. And once again, the degree of the top greater than the degree of the bottom, well, that again is rule number 1, which means that I have no horizontal asymptote. Now again, we talked about this. Rule number 1 means that there's actually an oblique asymptote. There's no horizontal asymptote because actually the asymptote is going to be slanted. And we'll work on finding those in a little bit. But for now, let's take the information I've got and show you what this graph would look like. Again, this is not going to be like the ones I would actually ask you to do for me on a test or quiz if you're taking this class with me, but it is still good practice for finding x-intercepts, horizontal asymptotes, and vertical asymptotes. We'll see here at the end of this set of notes the ones that you can expect to see from me. All right, so anyway, -2, I had a vertical asymptote right there. I had a x-intercept at -1, 0, so -1, 0. And then again, what this one's going to wind up looking like is if you were to use your graphing calculator to kind of confirm its shape, it do something like that and something like that. And then you can kind of see that that slanted asymptote would run somewhere kind of right through there. But anyway, not something I would expect you guys to be able to do for a couple of reasons. First, you wind up crossing that slanted asymptote, which makes this one a little bit weird. And both the functions come from the same direction, which again is not like that reciprocal function we saw in the previous section. So again, please take this problem for what it is. It is practice, finding x-intercepts, vertical asymptotes, and horizontal asymptotes. If I were to actually have you graph something like this, I would actually have you confirm your answer using a graphing calculator to see the shape, but I don't need to do that. There are plenty of problems that you can easily graph just finding the pieces, kind of the puzzle, putting them together, and then using the shape of the reciprocal function to graph it. So we'll get to those in a little bit, but let's try one more of these, getting some practice finding x-intercepts, vertical asymptotes, and horizontal asymptotes on the next page of the notes. I'll meet you guys there.